Maybe you'll come across a problem like this in your book where you have a sine x equals cosine x. They're just single powers. It's not like he uses a Pythagorean identity here. It's just sine and a cosine. No other substitution seems to work, so what you might try to do is square both sides. Because if you square sine, now I turned sine into sine squared, now you can use a Pythagorean identity and switch it into cosine squared, or at least 1 minus cosine squared. When you do this strategy, when you square both sides, you have to be careful because it will introduce extraneous solutions that you have to check. So an extraneous solution is, it looks like it works whenever you solve the equation, but if you stick it back into the original equation, it doesn't. So we have to be careful here. So on exercise 6, I have that same equation, so I'm going to try squaring both sides. So I'll have sine squared x equals cosine squared x. And take your pick. You can either turn the sine squared into cosine or cosine squared into sine. Let's just turn this one into the sine squared. So left side stays the same. Cosine squared, same thing as 1 minus sine squared x by the Pythagorean identity. Just add that sine squared over to the left side, so we have 2 of them. Equals 1, divide by our 2, and then take the square root. So sine x should be equal to plus or minus square root of a half, which is plus or minus 1 over the square root of 2. If you rationalize that, that's plus or minus root 2 over 2. Okay, on the unit circle, all the root 2 over 2's are at pi over 4, 45 degrees. All right, so this would be 1 pi over 4. Now before I write the general solution, what I'm going to do is I'm just going to get everywhere it would be between 0 and 2 pi and then check those, because some of them we're probably going to have to throw away. So we'd have another one at 3 pi over 4. That would be a root 2 over 2. Another one over here at 5 pi over 4. And 7 pi over 4. Those last two, those are the two negative ones. We have both positive and negative. Alright, so what we have to do is we have to check these back in the original equation. So sine squared has to be equal to cosine squared. That means they're both positive or they're both negative. With pi over 4, if I stick in pi over 4 for x, they'd both be square root of 2 over 2. They'd both be positive, so this one checks out. 3 pi over 4, if I stick it in here for sine, this one's a positive, but for cosine, it's going to be negative. So this one wouldn't work. In quadrant 3, 5 pi over 4, they're both going to be negative. Both the x-coordinate and the y-coordinate are going to be negative, so this one checks out. And just like the one over here in quadrant 2, 7 pi over 4, this time cosine is going to be positive and sine is going to be negative. So we'd actually have a positive equal to negative. That doesn't make any sense. So pi over 4 works, 5 pi over 4 works. If we were just talking about within the interval between 0 and 2 pi, those would be our two answers. Let me close that. So x would be equal to pi over 4 and 5 pi over 4. If I wanted a general solution for everything that would work, notice if I start at pi over 4, I can just add pi to it to get to 5 pi over 4. Add another pi to get back to a coterminal angle with 5 pi over 4, so it's just x equals pi over 4 plus n pi. That's the general solution.